Hi, Intermediate Algebra students. Happy Friday. Hopefully you're having a great day so far. So here we are. We're going to do our warm-up or recap of what you saw last night in the 10.3a video. If you didn't watch that, after you complete this video, I highly recommend going back and watching it because Miss Galt, who taught intermediate last year, made a video where she very clearly explains how to continue to find domain and range, but using the graph now. Okay, so you'll want to make sure you go back and see that. But here's a quick little recap of what she taught you. So as we are given a function, there's going to be two things that you have to be able to do. One, you'll have to be able to find maximums and minimums. And two, you'll have to be able to describe the domain and range. Okay, now with this function, if you wanted to, you could graph it on your calculator. Okay, we've learned how to graph, so I'm not going to show you how to do that. But what I see is that it is a quadratic, which means it's going to be a parabola. And again, the -3 is not with the x. So it's not grouped with the x, which means it goes up or down the same as what you think. Okay, so it's x squared minus 3 means it goes down 3. Okay, so that's what I know because I see the -3. It's going to be a parabola shifted down 3. So if I graph this, a normal parabola, again, if I want to show it, this is what we're shifting down 3. Okay, so I know this is what the x squared graph looks like, just continuing to practice transformations. So if I go down 3, I take the vertex, I move it down 3. That's the only thing that changed. So that's my new vertex. And it would be up and over like that. That's enough for me to get the picture. Now again, in this problem, all I'm asked is there a max or a min? Sometimes there's one, sometimes there's the other, and sometimes there's none. Parabolas, x squareds, will always have one. Okay? In this case, the vertex is the lowest point on the graph. And if it's the lowest point on the graph, then it is a minimum. Okay? So the function has a minimum. And the key to finding the minimum is we want the y value. Okay, so the y value is the minimum. So this is at -3. So -3. So the minimum is at -3. I think on Pearson, that's all it asks for. What is the minimum and where? So this is looking for the y value. If it asks the follow-up question of when x equals, the x value of that point is 0. But that's not as important. Again, this will typically be kind of what you're looking at. Is it a maximum or minimum? And if so, what is the y value of that point? Okay. Now, the next one, again, you would maybe need to graph this on your calculator. I'm going to quickly go through. Remember we said when a was negative, it flips it upside down. Okay. Again, it's a quadratic, so I know it's a parabola. The x plus 1, it's inside parentheses grouped with the x, so it moves it left or right, the opposite of what I think. So I see plus 1, I think right 1. So it's actually left 1. And the -5 is outside, so it moves it up or down, same as what you think. So this goes down 5. Again, I'm going to give you the graph, but then you're going to answer the question. Okay, so it's going to be upside down. That's what the negative does. The 2 makes it a little more narrow. We learned about that, but that's not as important if you're just asking minimum. All right, so I took the point that was at 0. I go left 1 and down 5. Again, don't plot a point at -1 and at -5. You go left 1, down 5. That's where your vertex is. And again, it would be a little skinnier, but more importantly, it's upside down. Okay, so again, you could have gotten that picture on your calculator, but now I want you to pause the video and see if you can figure out if the function has a maximum or minimum at what value. Hopefully in this one, you realize that the vertex is the highest point on the graph. Therefore, it is a maximum. Okay, we said it's down at -5. Okay, so your answer is the function has a maximum at -5. And again, if it asks this, it's actually when x equals -1. Okay, so it went over 1. All right, one more example. In 10.2, we learned about the cube root graph. Okay, so we know that the cube root graph, hopefully you remember, looks like this. And now the +2 moves it up 2. What that means is if I sketch a graph of this, that point of like where it kind of turns goes up to 0, 2. But again, it would just kind of be like this. Now here's the key about the cube root graph. This goes up forever, and this side goes down forever. If you ever have a graph that goes up on one side forever and down on the other side forever, that means there is no max or min. Okay, so in that situation, there's just no max or min. The same would be true if you had like a line. Okay, all right, so that's understanding the max and min. You're finding the highest point on the graph or the lowest point. And if it doesn't have one, if it goes on forever, then it's none. But if it has a highest point or a lowest point, that's a max or a min, and you're putting the y value. All right, last but not least, we also need to understand domain and range. And this is probably the harder one. So again, this is where once you find the graph, you may want to be able to watch the video to understand how to follow the graph to learn domain and range. Having said that, we actually did this in chapter or in section 1. So if we give you the equation, you can do what we've done all along. But otherwise, again, Ms. Galt does a good job of explaining how you can look at a graph. Okay, so this is the square root graph. So this is where we talked about, we're going to start talking about all different graphs at the same time. So I need to remember that the square root graph looks like this. The x plus 5, that is under the radical, so it shifts it left or right, the opposite of what I think. So since it's plus 5, it actually goes left 5. The minus 5 on the end is what it is, up or down, so it's down 5. Again, if I draw this graph, which I like to do, the original that we're talking about is like this. When we talk about shifting left 5, down 5, we're talking about moving that graph. So this is where we said, okay, go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and then plot that first point. Left 5, down 5. Once I have that point, I can just draw it up and over. And again, what we learned in this first section is that the domain is affected by the left or right. Well, my domain is now starting at -5. So we said x is greater than or equal to -5. Now in this section, though, we continue to use interval notation. Sometimes Pearson, I think Pearson actually always wants you in this homework to write in interval notation. So just make sure you read the directions carefully. This is called inequality. Interval notation, remember, you start with this value. So it starts at -5. That is a point on the graph. So remember, that's a bracket. If it goes on forever, it goes to infinity. Okay? So these would be the two different answers. Again, I believe Pearson asks for interval notation more often now, but either one. If it asks for inequality, give the first one. If it asks for interval, give the second one. All right, my range. Remember, that's affected by the shift up or down with the square root graph. So we went down 5, which means that the lowest point on this graph is at -5. So y has to be greater than or equal to -5 as well. But they're different -5s, okay? Or again, you could do -5, comma, infinity. Those say the exact same thing. Okay, one last problem. I want you to pause the video, write this down, and actually just describe the transformations. X minus 2 squared plus 4. So make sure you can describe what transformations happened. Hopefully you were able to see that the x minus 2 is grouped together, so that went right 2, opposite of what you think, and then the plus 4 should move it up 4. Now don't forget to ask yourself, what are we moving? Well, it's a parabola. Okay, so I'm going to sketch the graph with you so that we make sure we have the right thing. Again, what are we moving? If you want the visual, x squared, the parent function, looks like this. So I'm going to take that vertex and move it to the right 2 and then up 4. And that is where my point is. Now there is no a value in front, which just means it's 1, which means it's still just going up like this. Okay, now that you have the picture hopefully correct, I want you to pause the video, write down the domain and range, but I want you to write it both in inequality notation and interval notation. Okay, so make sure you take the time to pause the video and try this on your own. Okay, hopefully what you saw is that the domain is actually all real numbers. So I can't remember if Pearson says all real numbers. If it's all real numbers, technically it's negative infinity is less than x is less than infinity. That's how you would write it in inequality notation. But again, I think it either says all real numbers or In interval notation, it would be a parenthesis because we can't touch infinity, negative infinity, comma, positive infinity. Okay, so the good news about quadratics is that, or parabolas, is that the domain, no matter how you shift it, is always negative infinity to infinity. The range of a quadratic you have to be careful with because sometimes we do flip these upside down just like we did on the first one. If, though, it has a minimum value, which this one does, the range, the lowest point in this case was at 4, and then it goes up forever. So in inequality notation, you should have y is greater than or equal to 4. In interval notation, the 4 is a point on the graph, so it would be with a square bracket, but it does go up forever. So square bracket 4, comma, infinity with a parenthesis. Okay, so again, in this lesson, you'll have to be able to identify a minimum, maximum, or no minimum or maximum. If you get a max or min, remember it's the y value. And then also, given an equation or a picture, you have to be able to identify the domain and range. So more practice with that. All right, so your homework right now, and again, this video is about 12 minutes. So you are now going to go to Pearson and complete and submit your 10.3a Pearson practice. And then don't forget, before tomorrow, watch the 10.3b video. You'll probably have time, so before Monday, but you'll probably have time to watch the 10.3 or to do the 10.3a practice and watch the 10.3b video before you leave class today. Thanks so much. Have a wonderful weekend, and we'll see you on Monday.